The astronomical dilemma is perfect. You've probably heard about the discovery of 6 ancient galaxies whose astonishing mass contradicts the standard cosmological model. Until now, experts had hoped that the impossible formations might turn out to be other structures after all, but now the James Webb Telescope has detected another galaxy that is even older and equally massive. Consequently, researchers have to admit that their understanding of physics is not sufficient to explain the nature of the early universe. But what does this mean for the big picture? Does this mean that the Big Bang theory has finally had its day? And if so, how could the cosmos have come into being? When the James Webb Telescope set off into the gigantic expanse of space on December 25, 2021, it had a mission that was as simple as it was profound: to revolutionize our knowledge of the universe. And now, less than 3 years after the much-acclaimed launch from the McCann Space Center, it is already clear that the $10 billion device is fulfilling its mission with flying colors. Especially designed for infrared astronomy, Webb could in theory detect the heat of a bumblebee on the Moon from Earth. In practice, the highly sensitive infrared optics have already added the earliest active black hole, the morning star of the cosmos, and the oldest known galaxies to the star charts. Consequently, every new Webb discovery also holds new potential for knowledge, but sometimes that knowledge also consists of the fact that apparently everything we thought we knew about the structure formation processes in the early universe is wrong. Experts were first made aware of this fact at the beginning of last year. At that time, the James Webb Telescope identified 6 early galaxies that already existed 500 to 700 million years after the Big Bang and which, strictly speaking, should not exist at all. This is because, according to conventional cosmology, these early star clusters should have been quite small and low in mass. However, the universe is probably not particularly interested in our earthly models. The mass of the newly discovered galaxies almost corresponds to that of our Milky Way today. According to that data, all 6 structures had more than 10 billion solar masses of stars. One of them may have even cracked the 100 billion solar mass mark. In view of this, the lead astronomers from the University of Technology in Melbourne and Pennsylvania State University initially suspected that they had made a mistake, but despite all the checks and efforts, the data set still turned out to be correct. But why is this such a big problem? Well, because the mere presence of the astonishingly massive galaxies overturns virtually all current cosmological models. These say that the first stars were formed around 200 to 300 million years after the birth of the universe, but also that at the time the galaxies were detected, there simply wasn't enough normal matter to form so many stars in such a short time. However, there's also the possibility that at least some of these objects were dust-covered black holes. But even in this case, the astronomical crisis would not disappear into thin air, because this would also mean that there was already significantly more stellar matter in the very young cosmos than previously assumed. And if even one of these galaxies turns out to be real, it would go beyond the limits of our understanding of cosmology in detail. Either the density of matter in the early universe would have been 2 to 5 times greater than our models postulate, or the galaxies would have grown in a way that is completely unknown to us. The next impossible discovery, as befits the most powerful space telescope of all time, Webb is a true master at literally outdoing itself. Back in July 2022, astronomers proudly announced that they had identified the earliest known galaxy ever. In detail, Glass Z13 already existed 300 million years after the Big Bang. But now, Webb has also found a new galactic record holder. Researchers led by Stefano Carniani from the Scuola Normale Superiore in Pisa have found a group of stars that unfolded just 290 million years after the creation of the cosmos. Baptized with the scientific name JWST Z13-0, the galaxy already existed at a time when, according to common understanding, the first stars had only just been born. While this astronomical bombshell made the rounds at the beginning of June, the structure had in fact already appeared in the spring of 2023 in images taken by the Near-Infrared Camera, NIRCam. In the corresponding data, the experts recognized clear indications of a redshift of more than Z equals 14. To understand why this is so groundbreaking, we should first take a brief excursion into the world of cosmological redshift. There are different absorption lines in the spectra of different galaxies, and the absorption lines of distant galaxies are significantly more redshifted. However, the cause of the redshift is not the relative motion of the galaxy compared to the observer, but the expansion of space itself. In astronomy, the redshift is often specified in detail using the dimensionless quantity Z. If the measured redshift was Z equals 1, for example, the universe was just half its current size at the time the light was emitted. However, the mere redshift cannot reveal exactly how the corresponding expansion took place. And it becomes clear why the experts became so suspicious at a redshift of Z equals 14 when we consider that the previous galaxy record was Z equals 13.2. To reveal the true background of the surprisingly bright structure, the research team used the high-resolution NIR-SPEC spectrometer of the James Webb Telescope and realized that it even has a redshift of 14.32. The so-called Lyman alpha break, whose position reveals the extent of the redshift. All in all, the measurements left no doubt that this distant starry world already existed around 290 million years after the Big Bang. And yet, this is only half the astronomical truth. The galaxy may actually have been formed much earlier. Experts assume that it took around 100 million years to grow to the observed dimensions. However, it's not only the distant record and the associated early time of formation of the collection of stars that fascinate scientists so much, but also the fact that the galaxy must have already been very luminous. According to the experts' evaluations, it must have already comprised several hundred million solar masses of stars. And once again, the question arises as to how was this even possible? How could such a bright, massive, and large galaxy form in less than 300 million years? This mystery is compounded by the no less mysterious fact that the spectrum contains bright emission lines of hydrogen as well as oxygen, a finding that is surprising to say the least and which indicates that several very massive generations of stars had already gone through their life cycle before astronomers observed this galaxy. Ultimately, this unexpected discovery also proves that the previous research picture of the universe, with only small, still very faint galaxies, has had its day. And the researchers actually expect this change of heart to be further substantiated in the near future. According to them, the James Webb Telescope is likely to detect many more such impossible early galaxies in the coming years. Is the Big Bang theory still tenable? The discoveries just presented, and others, are currently causing more and more researchers to turn away from the established Big Bang theory. A brief reminder, this theory states that space, matter, and time emerged from an original singularity around 13.8 billion years ago. However, although the Big Bang is now regarded as an astronomical consensus, the correctness of which has been proven by the detection of cosmic microwave background radiation, even the proponents of this theory are confronted with a number of questions to which there are no clear answers. This applies in particular to the how and why. How can it be that 13.8 billion years ago something was created out of literally nothing? Can something form out of nothing at all? And was there a compelling trigger for this, or was it just a coincidence? Stephen Hawking emphasized that even time only began with the Big Bang, so this process could not have been set in motion by something or someone. No less confusing is the question of uniform radiation and density in the cosmos. Because no matter in which direction or at what distance we look, on a large scale, similar densities and distributions of galaxies, nebulae, and radiation exist everywhere. Conservative experts explain this with cosmic inflation. Other experts take this assumption and take it a step further. According to chaotic inflation, it is conceivable that this process only came to a standstill in a few bubble-shaped areas and otherwise continued forever. This also means that a magnitude of subuniverses formed in the bubbles, with each cosmic world containing its own individual physical laws. Against this background, a fundamental question therefore arises: what if the cosmos does not embody the big picture at all? Moreover, what if another universe existed before ours? Well, in this case, the Big Bang would turn into a big bounce. According to this hypothesis, concepts such as beginning and end are invalid in a cosmic context. What we commonly refer to as the Big Bang was in fact nothing more than a cyclical transition, because as soon as one universe dies, a new one emerges from it. According to this model, the universe, which is part of a multidimensional structure, is subject to an eternal rhythm of collapse and reconstruction. However, this is by no means the only explanation that has been put forward. Apart from the Big Bang theory, the most exciting and controversial theory of origins comes from the world of quantum physics and string theory. Allegedly, experiments have shown that the universe and everything in it does not actually exist. In simple terms, what we perceive as a visible universe is merely a flat hologram projected onto a sphere. Consequently, it is possible that we and our reality are the result of a superordinate simulation. What at first sounds like the plot of the next Matrix part can actually be reconciled with the so-called Kardashev scale. This categorization indicates how advanced a civilization is based on its energy use. If there really is a Type 3 civilization that's capable of using the total power of a full-grown galaxy, it could have succeeded in creating a perfect simulation with the help of a so-called Matryoshka brain. Whether we should really wish to know the truth about our cosmic home in this case, however, is another question entirely. A completely different question is whether you have already given us a thumbs up and a subscription. Become part of our community now and never miss a new video from us again.